Hi guys and welcome back. In this video we're going to learn more about for loops by creating a mathematical program that finds prime numbers. Let's start off by finding the prime numbers under the number 10. So we will do for n in range 2 to 10. And that means that we're going to get a new variable n, and it's going to be equal to 2 the first time that the loop runs, then it will be 3 the second time it runs, and then 4, and so on up until 9. We're going to start at 2 because it is the first prime number. Now, how do you check whether a number is prime or not? What you want to do is you want to see whether n is divisible by any number other than itself. So, how do we do that? Well, if n is 2, we know that it's a prime number because 2 is only divisible by 1 and 2. If n is 3, well, what we could do is we could check whether n is divisible by 2. And if it's not, then we know it's a prime number. So why is that? Well, imagine the number 3. There are only two numbers underneath it, 1 and 2. And we know that a prime number can only be divisible by 1 or itself in order to be prime. So the only number we have to check is 2. If 3 is not divisible by 2, we know it's a prime number. Let's move on to 4. For the number 4, we only have to check numbers 2 and 3. If 4 is divisible by 2, then we know that it's not prime. So for every number under the number we want to check, we need to see whether it's divisible or not. So what we're going to do is we're going to create another for loop that actually goes from 2 up to the number n. Remember, imagine we wanted to check whether 4 is prime, then we would check 2 and 3. If we wanted to check 8, then we would check 2, 3, 4, 5, 6, and 7. And what we do inside this inner loop is we say if n modulus x is 0, that means n divided by x gives you a remainder of 0, then we can print something like n equals x multiplied by n divided by x. And then we'll break. What this is doing is, imagine we are at iteration number 4. We will then start at 2, and we will say if 4 divided by 2 gives you a remainder of 0, then print 4 equals 2 times 2. And then we will break. Notice that the break keyword is inside two for loops. The break keyword and the continue keyword only affect the closest for loop to them. So only this loop would break. This loop here would not break. So what does this mean? Well, as soon as we find that n is divisible by x, that means that we know that n is not a prime number. So we don't have to check any more numbers. All we have to do is print that it equals something that can be divided, so it's not a prime number. However, imagine we've got iteration number 5. We will start with x is 2, and the remainder will not be 0, so we will not run this code. Then 5 divided by 3 will also not give you a remainder of 0, so we will also not run this code. Finally, 5 divided by 4 will also not cause to run this code. So, when the number is prime, this loop here will never break. Therefore, we can put an else keyword in this loop, which means if this loop runs to completion without encountering any breaks, n is prime. Let's run this, and you'll see the output. It's quite magical. You get 2 is a prime number, 3 is a prime number, 4 equals 2 times 2. Something interesting about this is you can see that as soon as we encounter one thing that it is divisible by, then we break, and we don't have to check whether 9 is divisible by 4, and then whether 9 is divisible by 5, and by 6, and by 7. As soon as we encounter that 9 is divisible by 3, we just stop, and that's it. So this here is actually quite a convoluted piece of code because you've got a nested for loop. And you're also making use of this else keyword that, again, most people don't know about. But hopefully it makes sense, and if you have any questions, please do ask in the course Q&A. As a small optimization, in case that you get asked in an interview or something like that, you don't have to check this loop from 2 to n. You actually mathematically only have to check from 2 to the square root of n. That's just how finding prime numbers works using Eratosthenes' sieve, but again, it's not really important for this code. Thank you for joining me in this video. I hope you've learned something, and I'll see you in the next one.